So we got our rational expression here. We're going to simplify it, and we're also going to look for restrictions. That's a big piece of this. The first thing we want to do is essentially try to factor as much as we can. In fact, this one is interesting. I can factor both the top and the bottom. So I'm going to do a little separating. I'll do this one in yellow and this one in green. I'm going to kind of separate the two of them, work on them individually, and then piece it back together as a rational expression or a very large fraction. I'll deal with the a squared plus a, okay? This can be factored. In fact, I can common factor a out of this. So when I do that, the a comes to the outside of a set of brackets, and then a squared divided by a. What you actually do is, because your bases are the same, you subtract the exponents. There's always an invisible one if you don't see any number written there for an exponent. So it's 2 subtract 1, which is a to the power of 1, which is just the letter a. Okay? And then a divided by a, that's like 5 divided by 5. It's just the number 1. So we have a bracket a plus 1. My a's look kind of funny, but that's what the numerator is supposed to say there.
Yeah, that's what I tried to do, but then instead of the 1, I put a, but I'm like, that would be a squared plus a squared.
Ah, yes. So it's the 1 value there.
Okay.
So that's our numerator, let's say.
Because technically it would be 1a, but you don't really say the 1, which should be p.
Exactly. There's a coefficient of 1 in front of the a. In fact, in front of both of them, we just, because it doesn't change anything, we leave it off to make it simpler to look at. The other one, a squared plus 2a plus 1. Okay. We can do sum and product again. It's usually the most common one. There is a coefficient of 1 there, so a times c, which just means 2 values that multiply to 1. Oh, that's interesting. 2 values that multiply to 1. Oh, yeah, that'll work. Good. And add to 2. Well, there's only 2 numbers that can really multiply to 1. And those 2 numbers can add to the number 2 also. So when we go to factor, we're actually going to get 2 sets of brackets. A will be the first term in both. And because it's positive 1, we have positive 1 and positive 1. So that's our denominator. So now what we're going to do is I'm going to highlight. This is what we're going to replace the numerator with, our factored form. And this is what we're going to replace the denominator with. This is also a factored form. So we'll end up with a bracket a plus 1 divided by, whoop, always do that. Forget to switch back to the, there you go. A plus 1 times a plus 1. Now, I would simplify, but technically before I simplify, you should always check for restrictions. I'm going to jump back to the right side of this page.
Yeah.
Essentially for a restriction, we want it to not equal 0. So we're going to split them. We want a plus 1 to not equal 0 and a plus 1 to not equal 0. Well, these are the same equation, so I don't need to kind of solve the second one. I just need to solve one of them. And in fact, it's just going to be a cannot equal negative 1 when we simplify.
Yeah.
We've got the same answer for the other one. So when we jump back here, let's go back to our rational. We've got our restriction here. I have a set that's the same. So I know they say it cancels out, but always remember it creates a 1. Technically, I'm going to just write this step in just so we remember it. This becomes a times 1 over 1, right? Because that also became a 1. Blah. Come on, machine. 1 times a plus 1. I'll carry out that multiplication. A times 1 is just a. And 1 times a plus 1 is just a plus 1. So that's our simplified version. We've simplified it to a over a plus 1. And we have our restriction of a cannot equal negative 1 in this equation. Okay.